Assalamu alaikum wa rahmatullahi wa barakatuh. In this lesson, we are going to talk about binary numbers. Binary numbers. In the last class, we talked about decimal numbers, and just like we count in base 10 in decimal numbers, we can also count in base 2 or any other number base. So in base 2, known as binary numbers, there are 2 digits. So basically binary numbers contain 2 digits, which is 0 and 1. So to differentiate between 10 in base 2 from 10 in base 10, we write 10 in base 2 as 10 base 2, like this. When we say something like this, ordinarily this is 10. If we leave it like this is decimal. But when we put base 2, or we write like this, 10 base 2, it means this is in binary. It is in binary. So therefore 10 without any word or number affixed is 10 in base 10. So when it remains like this without putting the base, so this is in decimal. So when we are talking about a binary number is a number that is made up of only 2 digits, which is 0 and 1. So just like we mentioned earlier in decimal number, the position of a digit in binary number determines the value of the digit. So just like in decimal, whereby we have units, we have 10 raised to power 0 for units. We have for tens, we have 10 raised to power 1. For 100, we have 10 raised to power 2. For 1000, we have 10 raised to power 3, in which this one is 10 raised to power 0 is equals to 1, 10 raised to power 1 is equals to 10, 10 raised to power 2 is equals to 100, and 10 raised to power 3 is 1000, and so on and so forth. So in binary, we count in twos. So for binary, we can say 2 raised to power 0. So for tens, we say 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, and so on and so forth. So just like this as well in decimal, when we have a decimal point, we start with tenths. So here we have 10 raised to power minus 1 for tenths. So we have 10 raised to power minus 2 for 100, 10 raised to power minus 3 for 1000, and so on and so forth. So for the binary numbers as well, we have 2 raised to power minus 1, 2 raised to power minus 2, 2 raised to power minus 3, and so on and so forth. So the place value of digits in base 2, it's more or less like that of base 10, which is the decimal number. So for example, when we have something like this, 1101 in base 2, we can further express it as, we say 0, 1, 2, 3. So we can just say 1 times 2. Since this is in binary, you can say 1 times 2 raised to power 3 plus 1 times 2 raised to power 2 plus 0 times 2 raised to power 1 plus 1 times 2 raised to power 0. Now we are breaking it down like this. Now we can simply say that 1 times 2 raised to power 3 is 2 times 2 times 2 plus 1 times 2 times 2, 2 raised to power 2 is 2 times 2, plus 0 times anything is 0, plus 1 times 2 raised to power 0, anything raised to power 0 is 1, so we write 1. So we have 1 times 2 times 2, 4 times 2, 8, plus 1 times 2 times 2, which is 4, plus 0 plus 1 times 1 is 1. So now what we are doing now, we are converting it to decimal. So if we add everything, 1 times 8, we have 8 plus 1 times 4, 4 plus 1, we have 8 plus 4, that is 12, plus 1, that is 13. So it means 13 in decimal is equal to this in binary. So it means 13 in decimal is equal to this in binary. So let's look at some other ones that have decimal points, like 1011.11. So similarly, we can just say here 0, 1, 2, 3. So we can just say here is -1, -2. So we can now say 1 times 2 raised to power 3 plus 0 times 2 raised to power 2 plus 1 times 2 raised to power 0. So for the decimal point, what do we do? So for the decimal point for here, so we have 1 times 2 raised to power -1 plus 1 times 2 raised to power -2. So we can simply say 1 times 2 raised to power 3 is 8 plus 0 times this is 0 plus 1 times 2 raised to power 0 is 1 plus, now in indices we can further express this as 2 raised to power, when we have 2 raised to power -1, we can further express it as 1 over 2 according to the law of indices. So we can say this is 1 times 1 over 2 plus, so plus this 1 times 2 raised to power -2. Similarly, just like in indices, 2 raised to power -2 will be what? 2 raised to power -2 will be what? 1 over 2 raised to power 2, which is equals to what? 1 over 2 raised to power 2 is what? 2 times 2, which is 1 over 4. So here we can say 1 times 1 over 4, so equals to 8. We add them together, we have 8 plus 1 plus 8 plus 1 plus 1 times 1 over 2, so we have 1 over 2 plus 1 times 1 over 4, we have 1 over 4. So we can further continue with this. 8 plus 1 plus 1 over 2 plus 1 over 4 gives us 1 over 6. So we have 8 plus 1, that is 9 own number, 1 over 6 as our final answer. So 9 over 6 is corresponding to this in binary. So I'm going to send the classwork that you are going to do. If you have any questions, please feel free to ask.